Okay, so now let's take a look at what we can do for dealing with two categorical variables at once. So for two categorical variables, we're looking at contingency tables and mosaic plots. And in terms of the commands, that table command that we just looked at in terms of one proportion, or one categorical variable, also works for this as well. In this case, if you're dealing with two categorical variables, you'll get a contingency table. And if you do the command mosaic plot of the table, you'll get a mosaic plot, which is used to see if there's any kind of relationship between your two variables. All right, so for this one, I'll go ahead and look at a company held a blood pressure screening clinic for its employees, and here are the results. So this is the blood pressure data set. And you can see here's the command to get it into R. So what I do is I'll click on read CSV, and again, this command I'll generally give you, if I ever ask you to use it, I'll generally give you the command, just copy and paste. And now you see BP, that's blood pressure, 474 observations, two variables. And if I look at it, the two variables, one is the blood pressure, and the other is the age. And normally those would be numerical variables or quantitative variables. In this case, they're both set up in terms of categories. That blood dot pressure is either going to be low, normal, or high. And then the age is either under 30, between 30 and 49, and then over 50. As far as the population, that's going to be all employees at the company. The sample is the employees of the company that had their blood pressure checked, which could be all of them, everyone, or maybe or most, or some. Anyway, we don't know at this point. It's an observational study. There's no attempt at a random selection. There's no treatment here. It was just taking a measure, observational study. As far as the variables of interest, one was the age of the employee, the other was the blood pressure of the employee. In terms of scope, scope really depends on, is about samples. So if you take every employee has their blood pressure checked, there really isn't a population inference because we've already checked the entire population. If we haven't checked everyone, there was no mention of random selection, so population inference cannot be claimed. As far as causal inference goes, it's an observational study. We can't claim causal inference. Some commands we can try. Again, it's very similar to for a single categorical variable. The str command gives you the structure of the data set. And that's kind of an optional command. It's for us right now. Really, when you have much more complicated data sets, the str command is a really nice command to have. Table, when you have two categorical variables, the table command will give you a contingency table. You can also divide by the sample size, become a relative frequency contingency table. And then if you do a mosaic plot with the table inside of that, you'll get a mosaic plot. Okay, let's try that. So let's start off. I'll type str BP, and you see there are 474 observations, two variables. Blood pressure is factor, which means categorical variable. We're high, low, or normal. Age is also a categorical variable. 30 to 49, over 50, and then under 30 should be the other one. If I run the table command, you see here I have the contingency table. So it's all these counts right here depend on on which cat levels you're at. So 51 you see right there is those are those that are between 30 and 49 that have high blood pressure. This 31 right here is those over 50 that have low blood pressure, and so on. If I put that inside the mosaic plot command, I get a mosaic plot. And let's say and generally what we look for a mosaic plot is we want the breaks to be about the same place in all of them. And at least there seems to be a little difference in terms of that middle column compared to the other two. Not a huge amount of differences, though. At that point, well, I mean, yeah, there definitely does seem to be a difference in terms of the hard to read. And the under 30, I guess, is the bottom. This bottom rectangle right here, under 30, seems to have a much more low blood pressure than the other age groups. One thing you do, so one thing you can do in addition, because if you notice that the categories go high, low, normal, really you'd want it to be low, normal, high. I mean, you want it kind of ordered. And there's like under 30, over 50, and then between 30 and 49. The order of these categories doesn't really make a lot of sense, because R kind of sets these up in terms of alphabetical. So if you really want to go out and reorder them to make it look nicer, and one thing I also like to switch these two variables, so blood pressure is the vertical and age is the horizontal. What you can do is create this command called factor. So you can see in the upper left, I have the commands already here. That is, I'm going to create this variable called age. It's going to be factor. When you see this BP $age, that's kind of set up. I'll talk about this more next week, next lab. But this is the BP is the data set name. This is BP data set. You see them upper right, and then I'm dealing with the age variable in that data set. So what I'm doing here is I'm going to reorder. I'm going to go ahead and reorder the categories, in terms of which one's lowest to highest. And since right now it's under 30 is, let's see, what's the order here? You can see, here we go. Hey, look at the contingency table on the lower left. 30 to 49, then over 50, then under 30. So I really want the under 30 to be first. And since right now that's the third one, that's what this part here is. That C312 means I'm going to do the under 30 first, the third category, what's the third level first, and then the first level, which is 30 to 49, and then the over 50. So if I try this command, I run it. Now, if I do table on that age, maybe. There we go. You can see now it's under 30 is first, then 30 to 49, then over 50. And that's kind of the order I want it. I'm going to do the same thing for blood pressure. Blood pressure went high, low, normal. I really want high to be the last one. So since high is first, I'm going to create a variable called blood pressure, set it equal to factor, which that factor command just means I'm going to reorder things. Data set, $, my variable blood pressure, and then the levels. And I'm going to say that 2, so the low is going to be first, normal next, and then high is going to be last. So I've run the command, and then do table. Now it's going to be low, normal, high. That's what I want. So now if I do a contingency table, I'm going to reverse the order. So I'll do age first and then blood pressure. You don't have to. That's just my own preference. But now you can see low, normal, high, under 30, 30 to 49, over 50. A little easy to read. And by making a mosaic plot of that, actually, let's do this. Of that table. You can see this is a little, this makes a little more sense. They're saying under 30 has the highest amount of low blood pressure. 30 to 49, there's more high blood pressure. You can see that the amount of high blood pressure is higher, and then over 50 has much more high blood pressure. The number of people with low blood pressure decreases as people age. So there does seem to be some kind of effect going on, that as people get older, they're more likely to have high blood pressure. So I guess I talked about this already. If you need help, by the way, I mentioned this before. If you want a little information about a command, you can always put a question mark in front of that command. So if you want to learn more about the bar plot command, then put a question mark around in front of that bar plot. And also, if you want to quit, you could type Q and then nothing inside parentheses. But for me, I tend to like just hitting the X here in the upper right corner. Ask you to save. It's up to you if you want to save or not. I'm not. And that's all for this week.